We want to prove cotangent theta minus tangent theta divided by sine theta cosine theta equals cosecant squared theta minus secant squared theta. Now, because we're proving this, we're not going to treat it as a true equality where we can do operations to both sides, and to the same thing to both sides to keep it equal. Instead, what we're going to do is work with one side of the equality and see if we can make it match the other side so that we are indeed proving that the two sides are equal. So we're going to start off normally with the side that looks more complex. So if I look at the left side, I see that there's more simplification that I can do to it than there is on the right side. So I'm going to start here with this fraction, and the first thing is I see cotangent theta. I'm going to rewrite cotangent theta as cosine theta divided by sine theta. And then I can rewrite tangent theta as sine theta divided by cosine theta. And all of that is over sine theta cosine theta. The right side, I'm simply going to bring down cosecant squared theta minus secant squared theta. I don't want to do anything with that yet. Now, looking at the numerator of this, I see a complex fraction, and I see that I have sine theta in this denominator and cosine theta in this denominator. So I basically need to get a common denominator. And the common denominator would consist of sine theta cosine theta. So I'm going to multiply this whole thing by sine theta cosine theta over sine theta cosine theta. Remember, numerator and denominator are the same. It amounts to multiplying by 1, so it doesn't change the value. When I multiply sine theta times cosine theta times cosine theta over sine theta, the sine theta in the denominator cancels out, and it leaves me cosine squared theta. When I multiply sine theta cosine theta times sine theta over cosine theta, the cosine theta in the denominator cancels out, and it leaves me sine squared theta, and that's a minus sine squared theta. In the denominator, when I multiply sine theta cosine theta times sine theta cosine theta, I simply get sine squared theta cosine squared theta. Now, looking at this, if I had cosine squared theta plus sine squared theta, that would equal 1, but I don't have an identity for the difference of these two. But what I do see here is that I have a single unit in my denominator, and I have a difference in my numerator. So what I'm going to do is break this apart into two separate fractions. Cosine squared theta divided by sine squared theta cosine squared theta minus sine squared theta divided by sine squared theta cosine squared theta. And when I do that, now I see cosine squared theta here cancels out, and that leaves me 1 over sine squared theta. Here, sine squared theta cancels out, and that leaves me 1 over cosine squared theta. And hopefully at this point you're starting to see 1 over sine squared theta is cosecant squared theta. 1 over cosine squared theta is secant squared theta. And so we do see now that this expression on the left, cotangent theta minus tangent theta over sine theta cosine theta, does indeed equal cosecant squared theta minus secant squared theta. So we have now proven the identity.